Hello everybody, I am Dr. S.S. Patil, Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we shall discuss about axially loaded short column design or design of axially loaded short column. Learning outcomes. At the end of this session, students will be able to analyze and design axially loaded short column. So they will be able to analyze and design the axially loaded short column. The axially loaded short column. A short column is one in which you will find the unsupported length in x direction divided by least lateral dimension b, and the unsupported length in y direction divided by least lateral dimension of the column d. The ratio are less than 12. So Lx by b, Ly by d are less than 12. So that is called as a short column. The assumptions already given in IS 456, what should be the permissible stress, this and that, everything. By considering all the assumptions, then we have to proceed further. All the procedure, everything is given in IS 456. We are supposed to strictly follow IS 456 and we should abide by. And IS 456 specifies that when minimum eccentricity does not exceed 0.05 times the lateral dimension, the member may be designed by using following equation. The equation is PU. PU is your factored axial load that can be taken by the member. 0.4 FCK, that is the stress considered in concrete. FCK is the characteristic strength. AC is area of concrete. AC is area of concrete plus 0.67 times Fy. Fy is yield stress of the steel. 0.67 Fy into ASC is area of longitudinal reinforcement or area of steel in longitudinal direction. So by using this equation, we can find out factored axial load that can be taken by that particular member. If helical reinforcement are used, helical reinforcement we use in case of circular columns instead of lateral ties. Lateral ties means without any helix. If you are providing only the perpendicular ties, they are called as lateral ties. The strength value given by equation 1, that is which we have seen in the last slide, may be multiplied by 1.05. That means 5% increment in strength can be considered, provided in such case the ratio of the volume of helical reinforcement to the volume of core shall not be less than 0.36 Ag upon AC. Ag is gross cross-sectional area of concrete, AC is area of concrete section, and minus 1 into FCK upon Fy. So this is the requirement to consider 5% increase in the strength. Now these are some of the important things which we are supposed to follow during the design. The cross-sectional area of the longitudinal reinforcement shall not be less than 0.8% nor more than 6% of cross-sectional area. That means it cannot be less than 0.8% and it cannot be more than 6%. Where bars are, the columns are lapped, in that particular case it will be maximum percentage allowed is 4%. Minimum is same 0.8%. And in case of column that has a larger cross section area, in that particular case we are supposed to consider the actual area required for supporting that particular load while calculating 0.8% of the required steel to be provided. Then the longitudinal reinforcement, The minimum number of bars to be provided are 4 in case of rectangular section and 6 in case of circular section, usually equidistant, provided equidistantly. Minimum diameter of the bars that can be used, this is very important, the minimum diameter of the bars that can be used is 12 mm. So less than 12 mm we cannot use in case of as longitudinal reinforcement in case of columns. The spacing of the longitudinal bars measured along the periphery of the column shall not be more than 300 mm. So maximum spacing between the bars is 300 mm. So these are requirements for the longitudinal reinforcement. Then lateral ties. So the reinforcement, these lateral ties are required to give a lateral support to the main reinforcement. If these reinforcements are not provided, the reinforcement may buckle and the failure of the column take place. The transverse reinforcement provided should satisfy the following requirements. So that means if phi is greater than, not greater than 135 degree, this is the way which we are supposed to tie the longitudinal reinforcement by lateral ties. If it is greater than 135, that means here it is 180 degrees. So there we can have the cut rings to tie the in the another direction the bars. Then the transverse reinforcement. Further, if the spacing of the longitudinal bars is less than 75 mm, the alternate bar may be unsupported in the other direction as shown in figure 2. So this is how we are supposed to take into consideration if the distance between the two bars is not greater than or it is less than or equal to 75 mm. So in that particular case we can consider this without any support in the another direction. Then the diameter of the ties shall not be less than 1/4 of the largest diameter of the longitudinal bar. The tie which we use for lateral tying of the longitudinal reinforcement should not have the diameter less than 1/4 of the largest diameter of the longitudinal bars or 5 mm. So therefore either 6 mm or 8 mm we use it for the lateral ties. So in case of the helical reinforcement, the pitch of the ties shall not be more than, rather not necessarily helical, it can be for the normal lateral ties. The pitch of the ties or the distance between the two lateral ties shall not be more than the least lateral dimension of the column. It should not be more than least lateral dimension of the column, that is width of the column, or 16 times the diameter of the smallest longitudinal bar. 16 times the diameter of the smallest longitudinal bar or 300 mm. So out of these three, whichever is more, that whichever is less, that we should consider, because it should not be more than all these three. It should not be more than all these three. Therefore, whichever is minimum of the three, that we are supposed to provide for the distance between the two lateral ties. That we call it as pitch of lateral ties or spacing of lateral ties. So now the pitch of the helical reinforcement. The pitch of the helical reinforcement should satisfy the following requirements. That means if its strength is enhanced by 5%, if the strength is enhanced by 1.05, that means 5%. So that means if we are considering the increase in strength by 5%, in that particular case we should observe very strictly that the pitch of helical reinforcement should satisfy the following requirements. Pitch means again the distance between the two adjacent windings of the helical ties. So helical ties is nothing but which is having a continuous from top to bottom. That means it is just wound around the main reinforcement. It should not be more than 75 mm. That is, the pitch should not be more than 75 mm. Not more than 1/6 of the core diameter of the helix bar. It should not be more than 1/6 of the core diameter of the helix bar, or it should not be less than 25 mm. That is for placing the concrete, and it should not be less than 3 times the diameter of the helix of the bar. Helix bars, diameter of the helix bars. So out of these T, we are supposed to see maximum and minimum, whatever given over there. So we are supposed to follow strictly with this if we are increasing it by 5%. If we are not increasing it by this 5%, then we can follow this above pitch only. If we are not providing or we are not considering increase in strength by 5%, in that particular case we can go for even pitch which is given by 4th class. So these are the important guidelines given by IS 456 for design of column, axially loaded short column. A review question: in any column that has a larger cross-sectional area than the required to support the load, the minimum percentage of steel shall be 0.8% of the required area rather than 0.8% of the provided area. Whether it is true or false, you please just guess. Then the cross-sectional area of longitudinal reinforcement shall not be less than 0.8%, 0.7%, 0.6%, 0.5%. Just guess it. If your judgment is right, the first answer, this is true. It's a statement is true. And the second, it is 0.8% of the longitude cross sectional area we are supposed to consider for as minimum reinforcement required. These are the references used for the preparation of this particular presentation. Thank you one and all.